Hello everybody, and you're at 5.8 and we're solving logs. All right, so solve the basic logarithmic equation. So what you're gonna do is, if you have two logs that are equal to each other and they have the same base, so remember that if you had log right here, that part is the base, okay? So if they have the same base and they're equal to each other, they can actually just cancel out. So then you have 3x plus 3 equals 5x minus 15. So it doesn't matter how you solve this, just make sure you solve for x. You get 3 equals 2x minus 15. Let's add 15 to both sides. 18 equals 2x, divide by 2. X is equal to 9. Now, we do have to make sure that this works. So you probably should have your calculator nearby. You're going to put log base 2 of, and we're just going to plug 9 back in. So you have 3 times 9 plus 3. Does that equal log base 2 of 5 times 3 minus 15? Okay? Not 3, 9. Awkward. Log base 2 of 5 times 9 minus 15. Okay, so put these into your calculator. Make sure that they equal each other, and they do. You have log base 30 does equal log base 2 of 30. So therefore, it is checked. Okay, so now let's look at the next one. You have log base 5 on both sides, so these can cancel out. And then you have x squared minus 12 equals 4x. Okay, now this is going to become a quadratic, so we're going to subtract 4x from both sides. And we get that x squared minus 4x minus 12 is equal to 0. Now let's see if this is going to factor out this way, or do we need to use the quadratic formula? So what multiplies to give you negative 12, but adds to give you negative 4, negative 6, and positive 2. So this goes to x minus 6, x plus 2 equals 0. We're going to set both of these equal to 0. And add 6 to both sides. We get that x equals 6, subtract 2, and x equals negative 2, okay? Now, when you're doing logs, you cannot have it, well, let's wait a minute. Okay, so let's check both of these. So we have log base 5 of 6 squared minus 12. Does that equal log base 5 of 4 times 6? Okay, so we have log base 5 of 36 minus 12, which will give you 24, does equal log base 5 of 4 times 6, which is 24. So this one can be an answer, okay? Now let's check the other one. We have log base 5 of negative 2 squared minus 12. Does that equal log base 5 of 4 times negative 12? Well, we do have that log base 5 of negative 8 does equal log base 5 of negative 8. However, you cannot have logs that have negative numbers like that, okay? So therefore, this one is going to become extraneous, okay? All right, so now let's go to the next section. We are going to be solving the following basic exponential equation by rewriting each as a logarithmic equation and approximating the value of x, okay? So remember our little loop-de-loop trick here? We've got, oh no, sorry, we have to write it as a log, okay? Oh yeah, we can do our loop-de-loop trick. So 2 to the 7 equals x. Well, 2 to the 7th power is 128. So now we're going to check, does log base 2 of 128, does that in fact equal 7? So put log base 2 of 128 into your calculator, and you will get that 7 equals 7. So there is our answer. All right, so we're taking this log and we're putting it into exponential form. So loop-de-loop here. We get 3 to the 4th equals 4x plus 1. Now 3 to the 4th is going to be 81. Equals 4x plus 1. Let's subtract 1 from both sides. 80 equals 4x. Divide by 4. X is equal to 20. Now we do need to check that. So log base 3 of 4 times 20 plus 1. Does that equal 4? Log base 3 of 81 Does that equal 4? And if you put that log base 3 of 81 into your calculator, you do get that 4 is equal to 4. So that is your answer. Okay, so let's move on to the next one. Now remember, ln is actually e, okay? So if I change this to e, well, let's do our loop-de-loop still. Well, that's like a log, well, let's rewrite this. This is log base e of x minus 3 equals 5. So now we have our loop-de-loop trick. E to the 5th equals x minus 3. E to the 5th, oh, let's just, that's a big number. So we're still solving for x, so let's add 3 to both sides. Now you have e to the 5th plus 3 is equal to x. That would be your legit answer, like your most exact answer. But now it did ask us to approximate the value. So into your calculator, you need to put e to the 5 and then plus 3. Make sure that plus 3 is not in your exponent. And when you do that, you get x is approximately 151.41. Now we do need to check this. So you're going to use the natural log button on your calculator. Does that natural log of 151.41 minus 3, does that equal 5? And you do get that they approximately equal. So that would be your answer. Okay, now again, this would be a rounded answer and this would be exact. So if you're asked to give the exact answer, you would give this one. Okay. All right, moving right along. We are going to use both of the techniques we just learned, and we are going to solve some log equations. So you want to get the log isolated all by itself. So to do that, we're going to subtract 5 from both sides, and you get log base 2 of 3x plus 2 is equal to negative 1. Now we can do our little loop-de-loop trick and say 2 to the first power is equal to 3x plus 2. Okay. Now we're going to subtract, well, we've got 2, right? Sorry, this is supposed to be negative 1 here. I forgot my negative. All right, so we were going to subtract 2. Now we have 2 to the negative 1 minus 2 is equal to 3x. Let's evaluate that left side real quick, because 2 to the negative 1 power is actually 1/2, and then minus 2 equals 3x. And 1/2 minus 2 is going to give you negative 1/2, or sorry, negative 1.5 equals 3x. Divide by 3 on both sides. X is equal to negative 1/2. Okay, so now we need to check this. Let's check it into our original. We have log base 2 of 3 times negative 0.5 plus 2 plus 5. Does that equal 4? And you actually do get that this is equal to 4 after you put it into your calculator. Okay, let's do the next one. Now we have plus, so we need to recall our properties of logs. Remember, when you have a plus, you're actually multiplying. So this becomes log base 6 of 9x times 4x equals 6. So log base 6 of 36x squared equals 6. And now we need to do our loop-de-loop trick. So 6 to the 6th power equals 36x squared. Now 6 to the 6th power is 46,656 equals 36x squared. We need to solve for x, so we're going to divide by 36 on both sides. And when you do that, you get x squared is equal to 1,296. We're going to take the square root of that. Now remember, when you take the square root, you get x equals plus or minus. And in this case, the square root of 1296 is going to be 36. So you need to check both answers. Okay, so let's check log base 6 of 9 times 36 plus log base 6 of 4 times 36. Does that equal 6? We're going to check x equals 36. Okay, and when you put that into your calculator, this side does actually give you 6, so we're good there. Now let's try x is equal to negative 36. We have log base 6 of 9 times negative 36 plus log base 6 of 4 times negative 36. Does that equal 6? And actually you get log base 6 of negative 324. There's no point of even continuing because you cannot take the negative, you can't take a log of a negative number. So this one actually becomes extraneous. Okay, so your only answer is x equals 36. That's the only one that works. Okay? All right, let's move on to the next one. We have 3 times ln of 2x plus 1 minus 2 equals 22. So just like a normal equation, we're going to add 2 to both sides first. And then we get 3 ln of 2x plus 1 equals 24. Divide by 3 because we're trying to isolate that ln. So we get that ln of 2x plus 1 is equal to 8. Okay, now remember ln can be rewritten as log base e of 2x plus 1, which equals 8. So e to the 8 equals this one. Okay, so we would subtract 1. E to the 8 minus 1 equals 2x. Divide by 2. X equals e to the 8 minus 1 all over 2. This would be your exact answer, remember. Okay, now it did say to approximate. So your rounded answer would be about 1,489.98. That would be your rounded answer. Okay, so now when you check this, you went and checked it. We've got 3 ln of 2 times 1,489.98. Sorry, I got distracted, so I don't know where I'm at. But anyway, so then plus 1 equals 24. So when you put all this into your calculator, you do get that 24 equals, or sorry, not 24, 22. That's awkward. Let me erase this real quick. Plus 1 minus 2 equals 22. And you do get 22 equals 22. So depending on what I asked for, if I asked for the exact answer, you would give me this one. If I asked for the rounded one, you would give me this one. Okay? Alrighty. So I would pause the video and I would try this all on your own. You do need to recall your log properties for expanding and condensing. Okay? So if you're coming back here, it's because you went and you tried this problem and you're checking it. So remember, if we have subtraction, that actually means division. But first we need to put our exponent up. So we have ln of 12x minus ln of 2 squared equals 8. Okay. So we've got, I'm going to go ahead and evaluate this 2 squared, which is 4. Okay. Now I can do my division. So I have ln of 12x over 4 equals 8. Alrighty. Now I'm going to go ahead and reduce what's on the inside. I have ln 12x over 4 is going to be 3x equals 8. Go ahead and rewrite that ln is actually log base e of 3x, and that equals 8. We're going to do our loop-de-loop trick. We get e to the 8 equals 3x. We're still solving for x, so we're going to divide by 3. X equals e to the 8 over 3. Now this would be my exact answer. Okay. Now my rounded answer would be, I don't think we need it. All right. So we're going to check. And when I check this, I get ln of 12 e to the 8 over 3 minus 2 ln of 2. Does this equal 8? We're checking. Okay. So when I put this in my calculator, I do get that 8 is equal to 8. And please ensure that you are actually checking it, because there will be problems where they don't equal. Okay. Alrighty. So let's go on to the next page here. We're doing some inequalities here. So what we're going to do is kind of treat this just like we would a equation. Okay. Now we have log base 2 of 3x minus 2 is greater than 4. We can't exactly do our loop-de-loop trick, so we're going to use our other trick of saying, okay, well, let's raise both of these sides to 2. And we do that because it's log base 2. If it was log base 4, you would raise it to 4. So now what's going to happen? These cancel. And you get 3x minus 2 is greater than 2 to the 4th power. And 2 to the 4th power is 16. So now we're going to solve as usual, right? We're going to add 2 to both sides, and we get that 3x is greater than 18 divided by 3 here. And we get x is greater than 6. Okay, so we also, though, we need to do the other side of this, which would be that 3x minus 2 is greater than 0, because we can't have right here, oops, sorry, let me get the highlighter out. We can't have that inside right here be less than 0, because if it was, then we can't work it out. So we do need to see what value it needs to be greater than. So we're going to add 2 here, and we have 3x is greater than 2 divided by 3. X is greater than 2/3. So we have these two constraints here. We have that x has to be greater than 2/3, so that way we don't have a negative log. And then our inequality, like our whole algebraic inequality, has to be greater than 6. Okay? So we'll put 2/3 here, and then we'll have, what, 6 over here. Okay? So now, if I have to have, well, here, we'll do this. 2/3 and 6. Okay? So it has to be greater. It cannot be equal, right? It cannot be equal to 2/3. It has to be greater. And then we also have 6, and it has to be open circle. Okay? So now, if it has to be greater than 6, there's no way it can be less than 6. So all the values less than 6 are not going to work. So if we are here, we have this one. So what I'm saying is this part right here, it can't even be that, because 6, it has to be greater than 6. So our answer is going to be 6 to infinity. Now, let's do another problem, okay? If I have log base 3 of 9x plus 9 is less than or equal to 4. Well, let's do the inside first. We know that the inside cannot be less than 0. So I have 9x plus 9 has to be greater than 0. Subtract 9. 9x is greater than negative 9. So x automatically has to be greater than 1. Okay, no ifs, ands, or buts. Now, let's try solving this. I'm going to raise both sides by 3. That cancels. I get 9x plus 9 is less than or equal to 3 to the 4th. 9x plus 9 is less than or equal to 81. Subtract 9 from both sides. You get that 9x is less than 72. Divide by 9. X is less than or equal to 8. Okay, so now when I draw this on my board here, I have 8 and I have negative 1. Both are going to be open. Okay, so x is less than 8. Okay, so we're going to go this way. But now the yellow says that x is greater than negative 1. So I have this kind of section right here. Okay, so we've got in notation, this is, oh, and I forgot to color this in because it is less than or equal to. Okay, so when I do my interval notation, I have parentheses negative 1 because parentheses go with open circles, and then I go all the way to 8, and it's going to have a bracket because it's closed. All right, so that would be my answer there. Okay, so let's go to the next one. I have to figure out the middle. Okay, so I'm going to go ahead and do that. I like to highlight it and put it in the same color. So I have x plus 2, and it has to strictly be greater than 0. So let's subtract 2 from both sides, and I get x is greater than negative 2. Now let's actually solve this. First, I have to divide by 2 on both sides to get rid of that coefficient. And I have ln of x plus 2, is less than 6. Now remember, this is actually log base e of x plus 2 is less than 6. So we're going to raise each side to the e. Those cancel, and I get x plus 2 is less than e to the 6. Subtract 2 from both sides. X is less than e to the 6 minus 2. Now I need an approximation, so let's see. If I put that into my calculator, I approximately get that x is less than 401.4. That's a big number. All right, so it's going to have an open circle, 401.4, because it's strictly less than. And then I have my yellow one, which x is greater than negative 2. So come over here, negative 2. X has got to be greater than that, right? But then the blue says x has to be less than that. So I'm going to be in between this right here. Now, interval notation is going to be parentheses because I have open circles, -2 to 401.4. Or I would prefer that you write -2, comma, e to the 6 minus 2, because we want exact answers most of the time. All right. So last one, and we'll get out of here. Log base 4 of 4x plus 20 is greater than or equal to 3. So remember, I have to do right here the inside. Okay, so 4x plus 20 is strictly greater than 0, so subtract 20 from both sides. I get that 4x is greater than -20. Divide by 4. X is greater than -5. Okay, now I have to solve my actual equation. So 4, we're going to raise it to 4, and I do that because it's log base 4, those cancel. And I get that 4x plus 20 is greater than or equal to 4 cubed. Well, 4 cubed is 64. So that 4x plus 20. We're going to subtract 20 from both sides. 4x is greater than or equal to positive 44. Divide by 4. X is greater than or equal to 11. Okay, so I'm going to come over here to 11. And it's going to be close, and x is greater than that. Okay, so I go that way. Now, -5 is going to be an open. Okay, and x is greater than that. Okay, well, that's great, but my blue says it has to be greater than 11. Okay, so it's great that the yellow's there, but the yellow doesn't even matter because blue wins, right? So my solution is going to be 11 to infinity. Okay, so that's it for this part. We will do the word problems in class. All right, bye.